Progress.
Hi guys, in this lecture we shall see guidelines for the disconnection process. We shall see first guideline, guideline number 1. What is the first guideline is disconnection must be corresponding to known and reliable reactions. This we can understand by taking an example. We'll take an example of ester, CS3, C double bond O, OCS3. This is the molecule under consideration. This is a molecule to be synthesized. So this is called as a target molecule. So we have to do the retrosynthesis of this thing. So what guideline says is disconnection must be corresponding to known and reliable reaction. I know the reactions. This ester can be prepared from alcohol and acyl halide. So my disconnection must be corresponding to known reaction, that is, this can be prepared from alcohol and acyl halide. So if I break here, if I disconnect here, what I will get here is CH3OH plus CH3 CO and X group. This is alcohol. This is acyl halide. I know these things, right? The ester will be synthesized from alcohol and acyl halide. So you should know the things before connecting. Before disconnecting, you should know what are the reliable things which we can reconstruct. So disconnection must be corresponding to known and reliable reaction. You should know what back things. And then we'll take an example. We'll take an example of ether. This is methyl ethyl ether. Again, this is a target molecule for us. How to disconnect means, again, the back reaction, the synthesis must be known and reliable reaction. We must break in such a way that we must know the reliable reaction. So I know that this can be prepared from, again, from alcohol plus alkyl halide, CS3, CH2, CH2. So this is the guideline number 1. Next, guideline number 2 is disconnect next to heteroatom. Disconnect next to heteroatom. This we shall understand by taking an example. Look at here, we have this big molecule. We got 2 parts here. This is the first part and this is the second part. These 2 parts are connected by sulfur group. The guideline says disconnect next to the heteroatom. So we got 2 possibility here. First one here and the second one is here. So again, we got a question. Next moment, this may be number 1 or this may be number 2 position. Where to disconnect means we have to disconnect at the second position. Why this is means we should take care that we should not cut next to the benzene group, because having reaction with benzene is very, very difficult. Because of this, first position is not a suitable place. Second place is suitable place. So we have disconnected here. If we disconnect means we will get a synthons. You know that this is a target molecule for us now. And you know that this is a retrosynthetic error. These are the synthons. And you know that for the synthons, there will be synthetic equivalent. For the first synthon, the synthetic equivalent is this. And for the second synthon, for this synthetic equivalent is this. This is the disconnection process. Next, we'll also write the synthesis of this one. We have taken both the synthetic equivalents and we added a base and we'll get our target molecule. So the second guideline is disconnect next to the heteroatom. Third guideline, don't disconnect the groups which are difficult to add. Look at here. If we disconnect here, it is very difficult to have. Why this is so means, I'll make you understand by writing the reaction. Suppose if we disconnect here, we have a acid group here, that is electron withdrawing group, right? We'll write ammonium halide, will write. So what will happen here is, this electron withdrawing group, where it will direct the incoming nucleophile means it will direct meta position, not at ortho, not at para. But look at here in our target molecule, we have the amine group in a what para position, but the reverse reaction is not possible. So what guideline says is, don't discard the groups which are difficult to do. It is very, very difficult to add para position, because already the electron withdrawing group already present here. It directs at meta position. So if this is a thing, don't disconnect these things. Next, guideline 4. If more than one disconnections are possible, disconnect all and then choose the one path which gives the right orientation. We'll understand this by taking an example. Look at here. In this molecule, we got a 2 ways. You can disconnect here, you can disconnect here also, right? First, you don't think about what is the right orientation, what is the wrong orientation. You first disconnect and then think. If you are disconnecting here, we will get positive charge will be there here, so alkyl halide, and this part it is here. And next here, if you are working here, means we'll get acyl halide and this cumin molecule will get thing. So this is the first part and this is second part. Then we have to choose between these things, which one is right and which one is wrong. First one, they wrote wrong here. You shall understand why it is wrong. Why it is wrong means I already told. And the benzene ring, electron withdrawing group is there. You know that electron withdrawing group directs at a meta position, means here or here. Here or here. So, but in our target molecule, where it is at para position. So again, addition of this molecule to the para position is very, very difficult. So this orientation is wrong. And they wrote second is right orientation. We shall check that. Look at here on the benzene ring, there is an electron donating group. You know that electron donating group directs at ortho and para position. Most preferably at para position. So this will be a right orientation. This is a synthesis. Take a benzene ring, add alkyl halide group, and AlCl3 means you know that thing. While having a reaction with the benzene, we need a Lewis acid. This is called as Priddlecraft alkylation reaction. Next, for this molecule, you're adding this acyl halide, you'll get your target. Guideline number 5. The group which is disconnected first will be added last. So disconnect the first inactivating groups, that is electron withdrawing groups. We'll understand this by an example. Look at here. What it is saying means, if the electron withdrawing groups there in molecule, you please disconnect those first. Why means, if they are comes-ins, once they are comes-ins, you know that they are inactivating and they direct at a meta position. So these electron withdrawing groups which are present on the benzene group will make us a lot of trouble. So you have to disconnect those first. If you disconnect first, you'll add last. So our problem is be solved. So we'll understand by taking this example. Look at here, NO2 is there. Here also NO2 is there. So what we'll do means we'll disconnect this first. So if you're disconnecting here means we'll get these things. Next we'll disconnect here. We got this thing, and this is a molecule. We shall get this in our laboratory very easily. Next we shall see the synthesis. By taking this molecule here. And for this, we added methyl sulfate. You know that methyl sulfate is very good methylating agent. So OH will become OMe. Next, tertiary butyl chloride will add in the presence of Lewis acid. This alkylation will be there. Next, for this, we'll do the nitration, means there will be nitration here and here. You'll get a target molecule. This is the guideline number 5. The groups which is disconnected first will be added last. So disconnect first the electron diagram because this will be added last. That is a better thing to us. If this comes first or second step, this will not allow do any further synthesis for that. This is the guideline number 5. Next, guideline number 6. If disconnection is facing a chemoselectivity problem, that can be solved by functional group interconnection. That will give a, if you are facing a problem of chemoselectivity, the functional group interconnection will give a solution for us. So shall understand by taking an example. Look at here. This is an example. What happens here? If we disconnect here, you know that CCl3, CS3 means electron donating. CS3 means it is electron donating, but it is CCl3. It is electron withdrawing group. If we disconnect here, addition of chlorine to again at para position is very difficult. You know that electron withdrawing group donates at a meta position. It directs incoming nucleophile at a meta position. So again, it is very difficult to have. This problem can be solved by functional group interconnection. What is that functional interconnection is? Before disconnecting, convert this CCl3 into CS3 by reduction process. Next, then disconnect this one. You disconnect here, right? You will have this molecule. Then take this last step, this you take, then add a chlorine, Lewis acid will be there, then we'll have a at para position substitution will be there. Next, you chlorinate it using PCl. PCl is very good chlorinated. So these are the 5 guidelines. What is the first guideline means? Disconnection must be corresponding to known and reliable reaction. Next, disconnect next to the heteroatom. Third one is don't disconnect the groups which are difficult to add. Fourth one is if more than one disconnection are possible, disconnect all and then choose the one which gives the right orientation. Fifth one, the groups which are disconnected first will be added last. So disconnect first electron group because these are trouble creating ones. Sixth one, if disconnection process is facing any problems like chemoselectivity, that can be solved by functional group interconnection. These are the 6 guidelines.